This section is about vectors. Why we want to learn vectors? That's because in the real life, there's so many variables they described by vectors. For example, velocities, force, all those things. Vector versus scalar, just like velocity versus speed. Okay. Speed is a number. Tell you how fast your velocity is. But the velocity is more than that. They have directions too. Okay, the vector in the three-dimensional space. I'm going to use A, I put the arrow on the top of it, which means it's a vector, just distinct from the scalar. In the book, they use a boldface. Okay, the vector in the three-dimensional space is a triple. A1, A2, and A3. A1, A2, A3, they are scalars. The vectors in the two-dimensional space only have two components. A1, A2, again, they are scalars. Okay, what do we mean by that? In the three-dimensional space, A with the arrow on the top is a vector. This vector is, okay, I give you triple, means I give you a point in the space. A1, A2, A3, okay. A1 is x coordinate, A2 is y coordinate, so A3 is z coordinates. Okay. Vector A is a vector like this, start as the origin and end up with a point A1, A2, A3. Okay. In the two-dimensional space, A1, A2, A1 and A2 is a point in the space, and the vector A there is always start as origin, end up with given point. Okay, so if I give you triple, you can consider is a point in the three-dimensional space or a vector. This vector is always start at origin, end up with the point described by A1, A2, A3. Okay, if I give you two vectors, vector A, A1, A2, A3, and the vector B, B1, B2, B3. Okay. Then we can define operators. Say additional, A plus B. Vector A plus vector B means corresponding component add together. B1, A2 add B2, A3 add B3. Similarly, you can define subtraction. Okay, in the scalar we have like addition, subtraction, multiplication, and division. Okay. Now you said, okay, how do we define the multiplication and the division for the vectors? You can say, okay, I define vector A times vector B is A1 times B1 as the first component, A2 times B2. You can define that way, but you can define anything you want. However, if you can define something which is no use, then this definition is not going to survive. Okay. We are going to define the two multiplication in the next two sections. Okay. So here we'll only define addition and subtraction for the vectors. Another thing we're going to define is a scalar times a vector. See, there is a scalar. Okay. Okay, scalar times vector has been defined this way. This scalar multiply each component of a vector. As a result, still a vector. Okay. So scalar times a vector give you a vector. important things I want you to know is like, okay, if I have a vector A and another is scalar times that, okay. Now I want you to know that if A is a vector like this, then scalar times that, C times A, will parallel with the given vector A. Okay, as I said, for the vector, we have a magnitude of that. We define the magnitude of vector A is like this. Square root of A1 square plus A2 square plus A3 square. What is that? X, Y, Z. Okay. Remember, vector A is with A1, A2, A3. Okay, and the origin as a point and end up with point A1, A2, A3. So the magnitude of that. Do we know how to find the magnitude? Yes, because we know how to find the distance between 2 points, right? What's the 2 points? One is the point A1, A2, A3. Another is the origin. So this one exactly is the formula to find the distance. Just subtract 0 for each component. Okay. I'd like to show you A and C times A. These two vectors are going to be parallel. I'm going to use 2D as an example, okay? A here is A1, A2. Then by the definition, scalar times that will be scalar times each component, CA2. Okay, say here is A1, A2. Okay, this is the vector A. Okay, so this direction can be measured by this angle. Okay. Then we have another one, say CA. CA end up with point CA1, CA2. Okay. So here is this is A1, okay, this is distance, this is A2. This is CA1, CA2. Obviously, those two angles will be the same, right? Because I call this theta, okay. Tangent theta equal to A2 over A1. If I call this theta 1, so tangent theta 1 will be CA1 over CA2, which will be A1 over A2. That means your theta equal to theta 1. So this means for given vector A, scalar times that, those two vectors will be parallel. Okay, they will be parallel. If C is negative, they will be like opposite direction, but it's still going to be parallel. In the other words, C there change the, okay, if you chose C is negative 1, if this is A, then this will be negative A. Okay. If C is bigger than 1, they change its magnitude too, make the vectors longer. Okay. Okay, another thing we need to know is how do we find a vector from given point P, say x1, y1, z1, and point Q, which is x2, y2, and z2. Okay, I have 2 points, okay, P and Q. So this arrow is important, okay? We denote this vector is P from point P to point Q, like that. This vector can be found by use endpoint coordinate, subtract starting point coordinates. minus z1. Okay. Now the order is important. Okay. The vector from point P to point Q is equal to minus vector from point Q to point P. Okay. Okay. I like to emphasize, say, for example, okay, I give you P here. I use 2D as an example. Say 1, 0. Okay. My Q here is 2, 1. I use the vector on the plane to describe it, which is easier. Okay. My point P here is, this is my point P, 1, 0. My point Q is here, 2 and 1. Okay. So PQ is this vector. Okay, let's find that. Two minus 1, 1 minus 0. Okay. Endpoint, which is a Q. So give you 1, 1. Okay. What is 1, 1? 1, 1, you can see I give you a pair. That means either you can think about give you a point on the plane or a vector on the plane. Okay. This vector will be like start as the origin, end up at the point 1 and 1. So look at these two vectors. If I call this A, okay. My vector A here is 1 and 1. And obviously this is a PQ, the same. Okay. This example tells you the vectors, two vectors will be the same if they have the same direction and the same magnitude. Okay. Doesn't matter where the starting point is. I can have something like this. There, the same thing. As long as the same direction, same magnitude, they will be the same. Okay. And there's three vectors. They are very important. One is I. Okay. I there can be written as 1, 0, 0. And the J here, let me write all of them. J there is 0, 1, 0. And the K here is 0, 0, 1. There are three very special vectors. X, Y, and Z. Okay. Now, 1, 0, 0. Remember, if I say this is a vector, let me put on the arrow on the top. Okay. Whenever you see the variable with arrow on the top, means it's a vector. Okay. They're not a scalar. Okay. How do we describe a vector? Remember, start as origin, end up at the point. This point is 1, 0, 0. So this vector is my I. Similarly, this is my J. And this one is my K. Okay, there's two ways to describe a vector. For example, I can write a vector, say 2, 1, minus 3. I just write something arbitrary. If I give you a triple, means I give you a vector. Okay, and this vector can be written in terms of ijk. Okay. 2 times I plus 1 times j and minus 3k. They can be written this way because I is a vector. Okay, scalar times a scalar times a vector means scalar multiply each component of the vector, right? J is 0, 1, 0, and the minus 3 times 0, 0, 1. Okay. So scalar multiply each of those. You got 2, 0, 0, plus 0, 1, 0, then minus 0, 0, and 3. Then you perform addition of the vectors. So they give you 2, add corresponding component together, 1 and then -3. Okay, so you can either write as a triple or something multiply I then plus. So one thing I want you to be careful, you don't write this way, okay? That's a common mistake. You don't write this way. This way means what? 2 times 1, 0, 0, and 0, 0, 1, 0, and -3, 0, 0, 1. Okay. Then you got something with like so many. So don't do that, okay? Don't do this. Your concept, this is once you write something like that, I will take lots of point out because this means your concept is not right. Okay, another sense is find a unit vector. Okay, now a lot of cases we need. Okay, first of all, let's say, what about a special vector I? What is the magnitude? Square roots 1 square plus 0 square plus 0 square give you 1. So J vector, special vector J is magnitude also 1. Okay, now we have let me ask you a question. I give you vector A, okay, which is A1, A2, A3. I give you vector means I give you triple. Its magnitude may not be 1, okay? Now, I give you A like that. Now, I'm looking for vector B. Vector B have same direction as vector A, however, its magnitude is 1. So the question, how do we find vector B? Remember, we say, okay, since we say vector A and vector B, they're parallel, right? The same direction. So vector B can be written vector scalar times vector A. Okay. If two vectors they're parallel, then one can be written scalar multiply another one. Okay. On the other hand, we want to magnitude of B is 1. Okay. So we take a magnitude of both sides. Let's assume C is a positive number. You can put that out. Okay. You can calculate the detail. You're going to figure out. You can pull that out. Okay. So this means what? C times multitude magnitude of vector A times C is 1. That means your C must be like this. 1 over magnitude of A. So you put back here, replace your C by this way you are going to find a vector B. Okay. Vector B is, remember, the coefficient of vector A is a scalar, okay? Scalar times A will not change. If this scalar is a positive, they will not change the direction of A, but only changes the magnitude. Let me give you an example. Okay. For example, the A there is 1, 2, and 3. Let me just write something arbitrary. Okay. Okay, now I want to find vector B. Have the same direction, has the same direction. With A, but the magnitude of B is 1. Okay. How did you do that? First of all, you have to find the magnitude of A, which is square roots 1 square plus 2 square plus 3 square. So give you what? 9 plus 4 plus 1, 14, right? Okay. Therefore, your B here, use that formula, will be 1 over magnitude of A, which is 1 over 14, then times A will be like scalar times the vector. That means scalar times each component times 1. Then 2 times that. Then 3 times. Okay, as I showed you before, scalar times the vector will not change direction. However, you can find the magnitude of B. You are going to see that is 1.